Okay, so 4.5.2 is going to be factoring polynomials. In chapter 4, we did factoring quadratics, but polynomials is where you're going to have a degree higher than 2. Okay, so quadratics is whenever it's x squared. You've done that. That's going to come back. We're going to talk about those as well, but polynomials is a full umbrella of anything that can be factored. So we will do GCF, difference of two squares, sum and difference of cubes, which is new for y'all, factor by grouping, which is new for y'all, and still trinomials. Okay. So GCF stands for what? Greatest common factor. So you should always look for your GCF first. That is always going to be step 1. Okay. No matter how many terms you have, no matter what the problem is, you always check for that GCF. Okay, remember that is the term that you can divide every single term in your polynomial class. Okay, and then when you have your variables, your variable has to be in each term for you to divide it out. So if it's not in every term, you can't take it out. All right, and then when you do take it out, remember it's your smallest exponent because you're dividing and you subtract your exponent, so you want that to be your smallest. So if I have 3x squared minus 6x, between 3 and 6, I could take out what? A 3. And then my smallest exponent is just my x. So I would divide each term by 3x. And remember that you bring that GCF out front, and then you open your parentheses, and you divide. 3x squared divided by 3x should just leave you with what? X. And then negative 6x divided by 3 is going to leave you with negative 2. Okay, so 3x times x minus 2 would be my answer. You could check it by still storing your number for x, whatever number you choose, type your original, type your answer, or you could just distribute 3x back in, and it should give you your answer. Okay. When we look at x to the 7th minus 5x to the 6th plus 11x cubed, if I'm looking at my coefficients, this is understood to be a 1. Between 1, negative 5, and 11, I can't take out a GCF because I have a 1. Okay, but I can look at my variables, x to the 7th, x to the 6th, and x cubed. Because I have an x in all 3 terms, I could take out what as my GCF? X cubed. So when you take out that x cubed, you are subtracting all of your exponents by 3. So x to the 7th divided by x cubed, I'm subtracting 7 minus 3, and that leaves me with x to the 4th. And then negative 5x to the 6th divided by x cubed is going to give me negative 5x to the 3rd power, because you're subtracting. And then 11x cubed divided by x cubed is just going to leave me with 11. Okay. And then I've got 4x cubed y squared plus 12x squared y minus 20xy cubed. So now I need to look at not just my coefficients and not just my x's, but also my y's. Okay, so if I look at 4, 12, and 20, what can I divide all of those by? 4. If I'm looking at x cubed, x squared, and x, what could I take out? X. And then y squared, y, and y cubed, I could take out y. So that 4xy would be my full GCF. And I divide each term. 4 divided by 4 is 1. X cubed divided by x leaves me with x squared. Y squared divided by y leaves me with y. And then I've got 12 divided by 4, which is 3. X squared divided by x is just x. Y divided by y is cancelled. So I don't have 1 remaining. Okay. And then negative 20 divided by 4 is a negative 5. X divided by x cancels. Y cubed divided by y leaves me with y squared. Okay. We good with GCF? Okay. Now the difference of two squares we talked about in chapter 4. That's when you have two terms separated with a minus. It has to be a minus because that's what difference means. And you have to have perfect squares. You should be able to recognize your perfect squares at this point. Okay. Your exponents need to be divisible by 2, so they're all even exponents. Okay, so my perfect squares include 1, 4, 9, 16, 25. You should hopefully know these. 36, 49, 64, 81. I'm just going to go up to 100. You should know them. I would like to think up to 15, but hopefully you can recognize them. If you don't know them off the top of my head, you can recognize them. Okay. Your perfect square variables, we're just going to say could be x squared, x to the 4th, x to the 6th, just anything that's divisible by 2. Okay. So your difference of two squares formula, if I have a squared minus b squared, then that's going to factor into a plus b, a minus b. So remember, all you're doing is taking the square root of both terms, and that's how you get those a and b's. And then one's a plus, one's a minus. They should be the exact same thing because they're conjugates. Okay? The difference of two squares, you have no work to show. You should be able to recognize your perfect squares and go straight to factored form. Okay? So if I have x squared minus 100, that is the difference of two squares. So my factored form, I have two sets of parentheses. One's a plus, one's a minus. X squared minus 100 factors into what? 10, yeah, and x minus 10, because the square root of 100 is 10. Okay. You could FOIL that, make sure the middle term cancels, that negative 10x plus 10x will cancel, and you're left with that x squared minus 100. Okay. If I have 9x squared minus 4, is that the difference of two squares? Okay. 9 is a perfect square and 4 is a perfect square, so that's the difference of two squares. I don't have a GCF to take out. So the square root of 9 is what? So it becomes 3x, and then the square root of 4 is, so 3x plus 2, 3x minus 2. Okay, when I have 100x squared minus 1, can I take out a GCF? No, I have a 1. Is that the difference of two squares? Yes. So I would factor that into what? 10x plus 1 and 10x minus 1. Very good. Now, when I get to 12x squared minus 27, can I take out a GCF? Yeah. If I'm looking and I only have two terms, I either have the difference of two squares or I have the sum and difference of cubes. So if I'm looking at my exponent, that's going to tell me what I'm dealing with. My exponent is squared, so it's a difference of two squares. Okay? I don't have a perfect square for 12 or 27, so that should be a hint you need to take out a GCF. Okay, so my GCF here would be what? 3. So 12x squared divided by 3 leaves me with 4x squared, and negative 27 divided by 3 is a negative 9. So then 4x squared minus 9, is that now the difference of two squares now that I've divided it by 3? Yes, so remember to take your GCF and bring it down, and then you'll split 4x squared minus 9 into what? And 2x minus 3. Now don't flip your page just yet. This little note tells you you cannot take the sum of two squares. It can only be the difference. There is no combination of two binomial factors that when multiplied will still cancel that middle x term, but give you a positive instead of the negative constant. Okay, so you cannot do the sum of two squares. Okay, now if I had something like negative 25x squared plus 16, it doesn't look like I can do anything, but I could take out what as a GCF? A negative 1. Remember that anytime you have a leading negative, you always take the negative out. So you always take the negative out as your GCF, even if there's no other number. So if I took out a negative 1, that would leave me with a positive 25x squared, now a negative 16, that has now created the difference of two squares. So be careful, you can't automatically say it's prime because you see a plus. If you can take out a negative GCF, it creates that. So then that would split into 5x plus 4 and 5x minus 4 with a negative 1 out front. Okay? So if you get to a problem that is the sum of two squares, so say x squared plus 9, you recognize it's a sum, you recognize you can't do it, you can either tell me prime or you can tell me not factorable. I'll take either way, prime or not factorable. Okay, questions on that section? Okay. So now we're going to move on to the sum or difference of cubes, and this is going to be new to y'all. Y'all did not learn this in Algebra 1. Okay, so now you've got options. When you have just a binomial that you're factoring, you're either doing the difference of two squares or sum or difference of cubes. Your exponent being odd or even will tell you which one is which. Okay, because your evens are the difference of squares, your odds are the sum or difference of cubes. Okay, I could not factor the sum of two squares, but I can factor the sum of two cubes. So you have to be careful with that. Okay, now your perfect cubes are not as, y'all don't have them all down as good as perfect squares, but hopefully you would recognize them. If you have we just did a few examples of your perfect cubes. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, and 4 cubed is 64. If you don't know your perfect cubes, it's going to be hard to identify if you need to take out a GCF or not, okay? But in your calculator, if you choose the math button and then go down to option 4, so math 4, that will allow you to check if a number is a perfect cube or not. If you're not familiar with them, that allows you to check it. Okay, so if you were to type in a number, say 216, and you get a whole number, that means it's a perfect cube. If you get an decimal, not a perfect cube, you probably need to take out the GCF. Okay, so you'll need to know math 4. Now your variables, because it's cubes, they have to be divisible by 3. So x cubed, x to the 6th, x to the 9th, and so forth. But you don't really get any higher. Okay, now my formula. Okay, I'm going to write out how you get each term. Once you get the formula down, sum and difference of cubes is not hard. Okay, so if I have a cubed plus b cubed, this a cubed we're going to call my first term. And then b cubed, we're just going to say the second term. So when you have the difference of two squares, we would square root it to get our factored form, right? So with sum or difference of two cubes, you're going to cube root the first and second term. So that a comes from cube rooting the first term. And then you're going to keep your sign. So if I start with a plus, it's going to be a plus in your binomial. Okay, and then to get the b, you're going to take the cube root of the second term. So similar to the difference of two squares, you're just doing cube root. This is going to give you your binomial, so that's two terms. Then you're going to create a trinomial based off of the binomial. Okay, the trinomial is 3 terms, and you create that from your binomial. So once you get that a plus b, you're done with your original problem. Okay, so what you're going to do is you're going to take your first term and you square it. And that's how you get that a squared, the first term in your trinomial. Then recognize that your sign changes. So I kept it at the beginning, then I change it. And then you're going to multiply your A and your B that was in the binomial. You just multiply the two together. Okay? This plus sign will always, no matter what, be a plus because you are squaring the next term and that's always positive. Okay, so you take that second term of your binomial and square it. Okay, it seems confusing, but it's really not. Once you do about 3 examples, you get it in. Okay. Now the difference of two cubes is the exact same. You just start with a minus, so this would be a minus and that would be a plus. The formula is still the same. Okay. So if I start with 8x cubed plus 27, okay, I check, do I have a GCF between 8 and 27? I do not. So I recognize that my exponent is a cube, so I should have perfect cubes here. Okay, if you don't know them, you can do that math 4 option, but 8 is a perfect cube and so is 27. So I'm going to create my binomial and then my trinomial. Okay, so the first term, I take the cube root of 8x cubed. So the cube root of 8 is what? 2, so 2x. I keep my sign. Start with a plus, so it's a plus. And then I take the cube root of 27, which is 3. Okay. Then for my trinomial, I take my first term, which is 2x, and I square it. So 2x times 2x is going to give me 4x squared. Then I'm going to change the sign. I make it negative. And then I multiply 2x times 3. I multiply the two terms together, and that's going to give me 6x. Then I'll always have a plus. This last term, I take my second term, which is 3, and square it. 3 squared is 9. Now, this trinomial that you create will not be factorable. So you just stop there. Okay, once you get the hang of it, you do not have to write this out at the bottom. This is just to help you see how to get your terms when you're looking back, when you're studying. Okay? Do we have questions on how I got that? So if I have x cubed plus 216, I recognize I have a cube for my exponent, so you should instinctively check 216 if you don't know if it's a perfect cube. Okay, it is. So I'm going to set up my binomial times my trinomial. I'm going to take the cube root of x cubed, which is just x. I bring down my plus sign. And then what's the cube root of 216? 6. So then I'm going to take my first term, which is x, and square it, which is just x squared. I change my sign to a negative. I multiply x times 6, and that gives me 6x. I always have a plus no matter what. And then I take 6 and square it, which is 36. Okay. Questions on that? Now, if I have 3x cubed plus 192, I recognize that I have a cube for my exponent, but 3 I know is not a perfect cube. So that means I should probably take out a GCF. So I would check, can 192 be divided by 3? Yes. Yes. So when you divide that by 3, what are you left with? X. Okay. Now I want you to factor that further, see if you can apply that formula on your own. Okay, when you factor that, what is your binomial? X plus 4. And then your trinomial should be
X squared
plus 16. How's that do? Good? Okay. So you have to be careful with that. Do y'all understand the formula? Okay. We have questions? Alright, so the difference of two cubes is the same thing. You just start with a minus, so you keep it minus, and then you change to a plus. But this last term is still always positive because it's squared. Okay? So if I have 8x cubed minus 1, I take the cube root of 8x cubed, and that leaves me with what? 2x, and then I bring down the minus. Cube root of 1 is 1. Then I do my trinomial. I take 2x and square it, and what does that give me? 4x squared. Change your sign to a positive. Multiply 2x times 1, which is just 2x. And then plus what? 1, because 1 squared is 1. Okay. So if I do x cubed minus 125, I want you to do that. What does that factor to? Very good. Okay. Now with this next one, we've got 27x cubed minus 64 y to the 6th. Okay. I would check, can I take out a GCF between 27 and 64? No. Could I take out an x? It's your instinct to want to because you see two variables, but those two variables are not there. So I can't take out anything. Okay. So when I take the cube root of 27x cubed is going to leave me with 3x. Bring down your negative. We know the cube root of 64 is 4, but when you take the cube root of y to the 6th, okay, we're going to have a whole section in chapter 6 where we do stuff like this, but this is telling you you have 6 y's. When you do the square root, you would do pairs of the same number, right? When you would simplify radicals. If it's a cube root, you want groups of 3. So how many groups of 3 can you get from 6? 2. So this would leave me with y squared. Okay, so then I take 3x and square it, and that leaves me with 9x squared. I change my sign to a plus. I multiply 3x times 4y squared. So 3 times 4 is 12, and then I write xy squared in alphabetical order. Then I have a plus. Now you're taking 4y squared, and you're squaring that. So 4 squared is 16. Y squared is going to give me y to the 4th. Okay, you understand the pattern? Okay, when we do factor by grouping, this is new to you. This is when you have 4 terms. You can only do grouping when you have 4 terms to start with. Okay? Now, some people, depending on who your teacher was, might have introduced trinomials and created 4 terms and did grouping, but I've never taught it that way. Okay, so grouping is when you start with 4 terms and you still check for a GCF. Okay, what you do after you check for a GCF is you're going to group the first 2 terms and the last 2 terms. Okay, so if I'm looking at my example, I'm going to check, do I have a GCF? Well, I only have 3, 2, and 6, but I don't have a coefficient greater than 1 here, so I don't have a GCF for my coefficients. I only have an X in 2 terms. I only have a Y in 2 terms, so I can't do anything with that. Okay. But my next step tells me I need to group my first 2 terms and my last 2 terms, and I leave that sign in the middle. Okay. Now, there is going to be something that you do if it's a minus, but if it's a plus, you leave everything as is. Okay. What you're going to do once you group it is you're only going to look at this first group, and that's going to be separate from the second group. Okay. Now that I've grouped this, can I take out a GCF with just this?
X squared.
I could take out an x squared. So if I take out an x squared, that leaves me with what?
Y.
Okay. And I have my plus. Now I look at only the second group. 2y plus 6. Can I take out a GCF there? 2. If I take out a 2, what does that leave me with? Y plus 3. Okay. Now see how you took out your GCF and you put it out front and you were left with a y plus 3. Same thing with this x squared. What do you notice now that it's looking all together? You have 2 y plus 3's, right? I have a y plus 3 in this term and a y plus 3 in that term. That's my new GCF. This is like a big GCF, okay? So what I want to do is I want to take that out. So I'm going to write that GCF, y plus 3 out front. And that leaves me with what? X squared plus 2. You factored by grouping. Okay, now you would check, can I go further? I can't go further with this. So this is all I can do. So you group it, you take 2 mini GCFs out, and you take that one repeated parentheses out of the big GCF.
Did you check this with like putting multiple variables like down in the calculator?
Yes, so if you wanted to do 5 stored for X, and then 5 stored for Y, it's fine if it's the same number. And you do X squared Y plus 3x squared plus 2y plus 6, you get a random value. And then if you do y plus 3 times x squared plus 2, you get the same value. Okay? Are good with that? So now if I'm looking at x cubed minus x squared minus 4x plus 4, okay? When you group this and you have a minus in the middle, put a star, do something, definitely make a note on your note card when you get one. You have to do something different, okay? When you separate it and there's a minus out front, that second parentheses, you're going to have to change the sign of the second parentheses. Because it's like you factored out a -1. When you are grouping that second set, it's like you factored out a -1, so you're going to change that, and it's going to flip its sign. So it becomes negative because it started positive. If it started negative, it would become positive. Okay? So think about when you were subtracting polynomials. You know how you change the sign to everything that comes afterwards? Now it's like you're doing the same thing, you're just taking out the negative. Okay, so it still changes signs. So I'm still doing the same process though. If I'm looking at x cubed minus x squared, what can I take out? X squared. When I take out x squared, what am I left with? X minus 1. X squared divided by x squared cancels to 1, not 0. It does not disappear. Okay, it cancels to 1. Then I've got my negative. Between 4x and 4, what can I take out? A 4. Now I've already accounted for my change sign, so that's going to leave me with x minus 1. You follow me? Okay. Notice I've got my big GCF now. So I've got x minus 1, and that leaves me with what? X squared minus 4. Okay, can I go further? What do I know about x squared minus 4? Difference of two squares. So I'm going to bring down my x minus 1. X squared minus 4 factors into x plus 2 and x minus 2. Okay. Now, what if you have 4 terms and you recognize you could take out a GCF at the very beginning? That's fine. If I have 6x cubed minus 18x squared minus 2x plus 6, I'm expecting you to recognize I need to take out a 2. When you take out a 2, that leaves you with 3x cubed minus 9x squared minus x plus 3. But then what do you need to do? I need to do my normal grouping. So you're going to have a set of parentheses within parentheses. Okay, so be careful with that. I'm going to group my first 2. When I group my second 2, what also happens? You have to change the sign because you have a negative. Okay, so this 2, I'm going to leave out front. And I'm actually going to put a big bracket. You don't have to. You can keep it in parentheses, but I'm going to do a bracket. If I'm looking at 3x cubed minus 9x squared, what could I take out for that mini GCF? 3x squared. And that would leave me with what?
X minus 3.
Then I've got my minus. I have x minus 3 here. Can I take out a GCF there? No. So I leave it x minus 3. Okay. I still have my 2 out front. Now I've got x minus 3 as my big GCF. And that will leave me with 3x squared minus what? 1. Anytime you're taking away itself, it's a 1. Okay, and you could even write a 1 right here if you wanted to. Now could I take that further? It's your instinct to want to, but 3 is not a perfect square, so that is all I could do. Okay, we good with that? So now what we're going to do is we're going to put it all together, every form of factoring, and we're going to solve by factoring. When it says solve by factoring, that's whenever you want to get down to x equals a number and x equals a number. This is where you have to have it equal to 0 every step. Now remember that? Some of y'all lost points because you wouldn't do equal to 0. That makes it the equation. You need it to be equal to 0 for you to solve for x times. Okay? So we're putting everything together. So your first step is you do GCF. If it's 2 terms, it's either difference of 2 squares or sum and difference of cubes. If it's 3 terms, it's a basic trinomial. 4 terms, you do grouping. Okay, so this puts everything together. And you will have a quiz where it's all mixed together. It's not separated by section like we just did. It's all going to be together, just like on your test. Okay, so you have to recognize what to do when. So if I'm looking at my first example, 3x squared plus 11x plus 8 equals 0. That's 3 terms. Do I have a GCF between 3, 11, and 8? No. So do you remember how to factor a trinomial? First times last. Multiply first times last, and that gives me 24. Factors of 24 to give me 11.
6 and 4.
That gives me 10.
Oh.
3 and 8. Once I get my 3 and 8, what do I need to do with that? You remember? If I multiplied at the beginning,
Divide by 3.
I have to divide it out, divide by 3. 3 over 3 simplifies to 1, but what do I have to put it over? X. And then 8 over 3 doesn't simplify, so I tack on x at the bottom. So my factored form would be x plus 1 times 3x plus 8 equals 0. You can write 3x plus 8 times x plus 1. The order doesn't matter as long as the sign is correct and the numbers right. Okay? Then, do y'all remember what we do there? You separate x plus 1 equals 0, 3x plus 8 equals 0. Make sure you put it in parentheses factored form together equals 0 and not x plus 1 parentheses equals 0 and 3x plus 8 parentheses equals 0. That's not what you do. Okay? Now, my x values would be what? X equals negative 1 and x equals negative 8/3. You would subtract your 8 divided by 3. Now that you're getting actual x values, you can store those in with your original matrix. Okay? Now, if I have 8x cubed minus 6x squared minus 20x equals 0, could I take out a GCF with that? I could take out a 2x. I'm going to bring that in front, and that's going to leave me with what?
4x squared.
Very good. Equals 0. So now I'm going to factor the trinomial in parentheses. So I'm going to multiply first times last, and that gives me a negative 40. What do I know when it's a negative? They have to be different signs. Okay? So factors of 40 that are going to subtract to give me 3. We have 1 and 40, 2 and 20, 4 and 10, 5 and 8. 5 and 8. Okay? Now I want a negative 3. So which one's going to be negative?
8.
The 8. Remember the larger factor takes the sign of the middle. And then I divide both of those by 4. 5 over 4 doesn't simplify, so the bottom takes the x. Negative 8 over 4 simplifies to negative 2. Write it over x. So I've got a 2x that I copy down. I have 4x plus 5 times x minus 2 equal to 0. Now, up until this point, you didn't set GCS equal to 0 because they were just constants. Now I have a variable, so I'm going to, every time you see an x, you should set it equal to 0. Okay? If you look at that leading exponent, that tells you how many answers you should have. Okay? So this 2x is equal to 0, 4x plus 5 is equal to 0, and x minus 2 is equal to 0. Divide by 2, x equals 0. Subtract your 5, 4x equals negative 5. Divide by 4, x equals negative 5/4. Add your 2, x equals 2. Okay? We good so far? All right, 2x cubed minus 3x squared plus 6x minus 9 equals 0. I have 4 terms. Do I have a GCF? No. What do I do with 4 terms? Grouping. So I group my first set, I group my second set. Do I need to change my sign? No, because it's a plus in the middle. So between 2x cubed minus 3x squared, what could I take out?
X.
X squared. That leaves me with 2x minus 3. Then between 6x and 9, what could I take out? A 3. And that leaves me with, if you take out a GCF and those two don't match, then you did something wrong with your math. But do not assume that they will always match. Okay? So now 2x minus 3 and 2x minus 3, I take that out as my GCF. And that leaves me as what?
X squared. Plus 3.
Equal to 0. Can I factor this further? No, I cannot. I'm still going to take my 2x minus 3 and set it equal to 0. This x squared plus 3, I set equal to 0 also. Okay? The 2x minus 3, I add my 3. 2x is equal to 3. Divide by 2, x is equal to 3 halves. When you get this binomial that doesn't factor, you're either going to use square roots for a binomial or the quadratic formula for a trinomial. So everything we've done with chapter 4 does not go away. Okay? So if I were to solve this, what would I do first? Subtract 3, so x squared equals negative 3. And then what do I need to do? Square root. When I square root, x is equal to what? Plus or minus I square root of 3. Y'all were all on the same path. I just have to put it together. All right. So plus or minus, because anytime you take a square root, you have a positive and negative solution. I have from what? Taking the square root of a negative and then square root of 3 would not simplify. Okay? Okay. 8x cubed minus 64 equals 0. What do I do? GCF. Even though 8 and 64 are both perfect cubes, I need to take out a GCF. My GCF here would be 8. That would leave me with x cubed minus 8 equals 0. Now, that's the difference of 2 cubes, right? Not squares, because my exponent is odd. Okay, so if I have x cubed minus 8, that's my binomial times trinomial. So what is that going to factor into? And then take x and square it.
X squared.
Change your sign.
2x plus 4.
Then plus 4. Now, I'm going to tell you this trinomial is not factorable. Factors of 4, to give me a 2, I've got 1 and 4, 2 and 2. 1 and 4 give me 5, 2 and 2 give me 4. Not factorable. So I will have to use my quadratic formula when I solve this. So if you are someone who just crams for one test and gets rid of the information and you're not bringing it to the next unit, you can no longer do that. You have to hold on to everything. Okay? Now, this 8, do I need to set this one equal to 0? Do I have an x on it? No. So I don't have to. If you want to, 8 is equal to 0, not a true statement. Okay? X minus 2 is equal to 0. And then x squared plus 2x plus 4 equal to 0. I still have to equal it to 0 before I do my quadratic formula. Okay, so x minus 2 equals 0, add your 2, x is equal to 2. Do you remember your quadratic formula?
minus 4ac divided by 2a.
Okay, so make sure you have your x equals on that. You're solving for an x value. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You have to know that. You might get a note card on your test, but you're not going to get one on your quiz. Okay? So this is where we did our A, B, C, and 4ac. Y'all remember that? Hopefully. My A is what?
X.
So my coefficient is 1. My B is, my C is, so 4 times 1 times 4 is 16. So I've got x equals negative, and then plug in your 2, plus or minus the square root of 2 squared minus 16 all over 2 times 1. Clean it up. X equals negative 2 plus or minus the square root of 2 squared minus 16. Remember, you could type that in your calculator. That's 4 minus 16, which is a negative 12 all over 2. Now, what do I do with the square root of negative 12? I do my prime factor tree. That splits 2 and 6, 2 and 3. So this is really x equals negative 2 plus or minus what? 2i square root of 3 over 2. Divided by 2. I don't need that fraction bar. I'm just going to make it a box. I don't need a fraction bar because it's going to be over 1. So this is just going to be negative 1 plus or minus 1i square root of 3. There's a lot to that. You have to know it. Okay? Do you have questions on it? We got 2 more. We're going to kind of zoom through these. What do I do first step for this one?
GCF.
Do I have a GCF? No. So what do I need to do? Group them. What happens when I group them? Change the sign. Good job. So between 3x cubed minus x squared, what do I do? Take out an x squared, and that leaves me with good. Minus, what can I take out between 27x and 9?
9.
And that would leave me with 3x minus 1 equals 0. So then, how do I write my next step?
And then x squared by.
That 3x minus 1 comes out as my GCF, and then that leaves me with x squared minus 9 equal to 0. If you solve x squared minus 9 using square roots, it's not going to be right because you're supposed to factor the whole way. That is the difference of two squares. Okay? So 3x minus 1 comes down. X squared minus 9 factors to what? Equal to 0. And then I do my 3x minus 1 equals 0, x plus 3 equals 0, x minus 3 equals 0. For time's sake, I'm just telling you x is equal to 1/3, x is equal to negative 3, and x is equal to positive 3. Okay? I know that it's a long set of notes, but are we hanging in there? We know what we're doing? Or x cubed minus 4x equals 0. What do I do? GCF, what's my GCF?
4.
Alright.
For x. If I take out 4x, what does that leave me with? X squared minus 1 equal to 0. Then what do I do? Difference of two squares. So I bring down my 4x. X squared minus 1 factors into what? X plus 1, x minus 1. So I've got 4x equal to 0, x plus 1 equal to 0, and x minus 1 equal to 0. Divide by 4, x equals 0. Subtract your 1, x equals negative 1. Add your 1, x equals 1. Okay? That's all your factoring put together. Factoring will not go away. We will do that later on in the year also. Okay? You have a quiz over this next class. So make sure you start your worksheet today. I would do like half today, half tomorrow. Make sure you're refreshing and don't forget about it. Okay? So we'll see y'all Thursday. You've got your quiz and then we'll start synthetic division. Okay?